Hello everyone, I am Ganga Bhavani working as assistant professor in IT department, St. Martin's Engineering College. Today I am going to deal with the subject machine learning. I am taking the concept candidate elimination algorithm. So let us go. First we will see what is machine learning. So in machine learning, it is a subset of artificial intelligence that allows the computers to learn from the past data. Okay, so we will see within a simple video here. So here the video shows how we are going to deal with the machine learning. It is going to how it is enhances in the day-to-day life. So here let us see. See, machine learning. So it is going to we are used in many industries, technologies and professionals to enhance the day-to-day life here. So here let us see what is the machine learning. Machine learning is a subset of artificial intelligence. It uses the statistical techniques to improve the performance of the system. The systems will become more intelligent here. So it is used in many multiple fields and industries here. So let us see, it is used in medical diagnosis, face recognition, image processing, and we are using in the like face recognition also. So we are going to see how the systems are becoming more intelligent here. So by using the machine learning algorithms, what are the algorithms here? They are using the past data. So next, so we are talking about past data. Here it is consistent and we are talking about non-consistent here. So let's go to the topic. Before moving to the topic, we will see what is the machine, what is the concept, candidate elimination algorithm we are using here. So in machine learning, so I am talking about the machine learning here. So in machine learning, I'm using candidate elimination algorithm. So candidate elimination algorithm computes the version space. What is this version space? Whatever hypothesis I'm taking, they should be consistent with the positive examples. Okay, next. So already we are having the finders algorithm here. Then why we are using candidate elimination algorithm? Okay, we will see. What is the reason is it is having a drawback here. What is the drawback we are having here? So it is having a problem like it can deal with only the positive examples. So positive examples. First we will see what is this finders algorithm. So in finders algorithm, it is a simple machine learning algorithm used for the concept learning. So we will see what is this concept learning actually. So concept learning, if I'm taking the universe of mobiles, I'm taking the universe of mobiles, I want to know about the mobiles here. So if you want to know about the mobiles, so first we are having many tablets. So we are having smartphones. When coming to the mobiles, we can talk about the smartphones. So is it that much easy to do all this? Is it that much not easy to deal with everything, tablets and smartphones? But if you want to recognize whether it is a tablet or whether it is a smartphone, they are going to have some features like shape and everything. So we cannot study everything. So what I'm taking here is I'm taking just the concept. What is this concept here? I'm just taking some features in order to tell the tablets and smartphones are different. So we are dealing with just a concept learning. So when coming to concept learning, why we are dealing with finders algorithm here, we are going to see now. So finders algorithm, it is going to deal with the concept learning. It is a machine learning algorithm. Okay, let's go into the concept. Just now I have talked about the concept learning here, about the mobiles and tablets I'm talking. So here we are going to call it as the inductive bias. Means we are going to know only little thing about the concept. Just we are dealing with a small amount of concept. We are not going to study total universe of the mobiles. So here the machine learning is selecting only the finders algorithm. Okay, let us see what is the finders algorithm. Finders algorithm, it deals with only the specific hypothesis here. So what is the specific hypothesis? It is going to take only the particular values. So what are the particular values we are going to see now? So till now I have talked about machine learning. Next I am going to tell about the candidate elimination algorithm. Before that we are going to see what is the finder's algorithm. Finder's algorithm is a simple machine learning. It is used for concept learning. I am talking about that. Then what is the problem with the candidate elimination algorithm? It can deal only with the positive examples. So why it is not able to use the negative examples? Okay. So if you use the negative examples, it is unable to target on the negative examples because it is in finder's algorithm we cannot learn the negative examples, but it may create lot of impact on the concepts. That's why let us see what is this finder's algorithm. So finder's algorithm, we will see first we have to initialize the most specific hypothesis. Okay. Next, you have to first take the positive training example. You have to take the positive training example here. Next, you have to initialize the constraint. Next, if it is not consistent with the positive example, you have to replace with the most general constraint. So we will see what is that. What is every time I am talking about the most specific hypothesis and I am talking about general hypothesis. We will see what is this most general hypothesis and most specific hypothesis. Okay, so here in most specific hypothesis, it will take any value. Whereas when coming to the most specific hypothesis, it will not accept any value. Okay, so the most general hypothesis we are taking as a question mark here, and for specification of most specific hypothesis, we are taking the null values. Okay, so let us go into the example first. We are going to apply the finder's algorithm here. So I am taking this table. It contains the 6 attributes: sky, air temperature, humidity, wind, water, forecast and enjoy sport. When coming to the enjoy sport, we have 3 yes and 1 no. 3 yes means it is a positive example, 1 no means it is a negative example. So it is not acceptable, negative example means. So here I have taken the features for each attribute. For sky I am taking it is, why I am taking this enjoy sports? I want to know whether the person is comfort on which day to play the game, sports. So we will see, we are going to check what is sky, air temperature, humidity, wind, water, forecast and enjoy sports is nothing but the output created. So we are going to apply this finder's algorithm on this table. Okay, let us go. So here, first example I am taking as the positive example, and I have already told you that in finder's algorithm, first you have to initialize with the most specific hypothesis. Why we are taking most specific? Why we are not taking most general hypothesis? In most specific hypothesis, finder's itself, its S is specifying that it is very much specific here. Okay. So here, first I am going to initialize the finder's algorithm with the most specific values. That is nothing but I already told you that most specific is nothing but it is we are denoted by the null values. Why I am taking these 6 null values here? Because for the 6 null values, because we are having the 6 attributes in the given example, you have to take 6 null values. It is preferable. Next one, I am taking the first positive example. In that, what are the attributes we are having? Sunny, warm, normal, strong, warm and same. That is a positive example. So it is good to listen that we can use a positive example in the finder's algorithm. So what I am saying is, if it is not consistent with the given hypothesis, then what you have to do, you have to replace that one. Okay, so the hypothesis is the null values. We are having 6 null values. So I am checking with a positive example. They are not at all consistent. So what I am doing, I am replacing the hypothesis with the first example. So H1 is this one, we have got sunny, warm, normal, strong, warm, same as it is whatever you are having in the positive example. So next we will see, let's go with the second example. So for the second example, H1. So consider the second training example. So it is, so what we have to do, it is also not consistent with the middle value. I am taking as the question mark. So next I am taking this one, like third example. Third example, what happened? It is a negative example. Already I have told that finder's algorithm is not consistent. Okay, so as it is a negative example, we just ignore the negative examples in the finder's algorithm. So coming to the fourth example, we are taking sunny, warm, high, strong, cool, change are there. This is the positive example we are having. So what you have to do, you have to compare this fourth example with the hypothesis H3. Okay, so which one is not consistent? Just you have to replace with the most general hypothesis. What is the symbol for most general hypothesis? We are having as question mark. So what I am doing, I am replacing with the question marks. Wherever it is not consistent, I am going to replace it. So therefore, the output we got for the finders algorithm is sunny, warm, question mark, strong, question mark, question mark. So here, but this data only accurate for the positive examples. And what about negative examples? It is a very, very big drawback in the finders algorithm. So what I'm doing, I just went to the candidate elimination algorithm. The good thing about candidate elimination algorithm is it is going to deal with both positive examples and negative examples. Every time I'm talking about positive and negative examples. What is this positive and negative examples? So we are training the system actually. When machine learning itself, how it is going to learn, I'm not giving any programming in the machine. How it is learning, we are going to give the past experience. We are going to give the past experience, means training we are giving to a machine. If you want to give the machine every time, how can you give the positiveness? So some drawbacks also we are going to have. It has to learn the drawbacks also. Okay, so coming to the drawbacks, so what I find as algorithm, it is not dealing with a negative example. Then what we have to do, you have to take both positive and negative examples. So the candidate elimination algorithm computes the version space containing all the hypotheses that are consistent with the sequence of training examples. So we will see first what is this version space. Version space means it contains all the hypotheses, all the positive which are consistent with the given hypothesis only. So here we will see what is this consistent. Let us see the consistent. What is the meaning of a consistent? I want to show you. Yeah, consistence means it creates a positive values within this. Okay. So next, so let us see what is consistent. First, when we see about the candidate elimination algorithm, let us see what is that algorithm first. So the better thing is a positive candidate elimination algorithm is we are going to use more specific hypothesis and most general hypothesis here. When coming to finders algorithm, I have taken only the negative is ignored in the finders algorithm. The good thing here about candidate is it is accepting both most specific hypothesis and most general hypothesis, and also it is accepting positive examples and it is also accepting the negative examples. And why we are using all this is in order to find the concept learning. The before lecture I have told you that the concept learning how we are going to use here. Okay, so when coming to the candidate elimination algorithm, first we will see what is this candidate elimination algorithm. So first we have to initialize the most specific hypothesis, most general hypothesis you have to initialize. So first if it is a positive example, then first you have to go to the most general hypothesis you have to go. There you have to check whether it is consistent or not. If it is consistent, no need to change, no need to replace anything. Then go to the most specific hypothesis. In most specific hypothesis, if it is not consistent, just change the values of the hypothesis. Okay, the repeatedly. Then coming to negative, if you get the negative example, then what you have to do there? So till now I am telling that for positive examples, you have to go to the most specific hypothesis. So what we have to do for the negative example, first you have to jump to the most specific hypothesis. You have to check whether it is consistent or not. Next you have to come to the most general hypothesis. This process will be repeatedly happen until you get a solution. Okay. So here same example, in order to not get the confusion, I have used the finders algorithms. For same enjoy sports I have used in finders. Now I am using for the candidate elimination algorithm. Okay. So the same example I have used enjoy sports, means whether the person is in which day is comfort to play, depends upon the weather, how he is comfort. So here in this example I have taken the 4 things here, sunny. So what I have taken for the first example, second example, third example, fourth example. So here in the first example it is for positive example, second one is also positive, and third one is negative, and fourth one is positive example. So here I already told that the drawback we are covering in the candidate elimination algorithm. What is the drawback I told you just now? It is a finders algorithm. It cannot deal with the negative examples. So that problem is solved in the candidate elimination algorithm. So what I am going to deal with third example also here. Third is a negative example now. So here I already told that we are going to use two methods here, most general hypothesis and most specific hypothesis. Whereas in fineness algorithm, we used only most specific hypothesis. We have initialized only with the null values. But here in most general hypothesis and most specific hypothesis, we are going to initialize here. So first I'm starting from here. See here, first G naught I'm taking. So most general hypothesis I'm denoted by G naught here. So I am taking with the question marks. I already told this most general hypothesis we are going to take the question marks. Next, coming to the most specific hypothesis, I am going to initialize with the null values. Why I am taking 6 null values? Because whatever attributes I am having are the 6 values here. Don't think that enjoy sport is also an attribute. It is an output. It is telling whether the given training examples are positive or negative. Don't consider it as a seventh attribute. So we are not using the seventh attribute here. It is not an attribute. It is an output actually. So here we have three. It is showing that we have three attributes, three positive examples, one negative example in the given example. It is an enjoy sport. I'm repeating that in fineness algorithm, we are not at all using the negative example. In candidate elimination, we are using the both positive and negative examples. Why we should use the negative example is, if in order to get the accurate output, it is very much compulsory. We have to use the negative examples. Okay. So here let's see. I'm going to initialize G naught and S naught. G naught is most general hypothesis and S naught is the most specific hypothesis. Most specific hypothesis I want to tell you, like, it will not accept any value. The null value itself, null value means it is not accepting any value. When coming to the most general hypothesis, question mark means it is going to accept each and every value is acceptable here. If you are taking a specific value, if I am saying it is a specific value, so we are not going to change any value there. Okay. So let us start with that algorithm. So in candidate elimination, first you have to initialize the most specific hypothesis, most general hypothesis. So I am denoting the most general hypothesis with the G naught and most specific hypothesis with the S naught I am taking. So in G naught I am taking 6, as they are the 6 attributes, we are taking the 6 question marks. Here also same thing, I am taking the null values. Let us go into the example. In the enjoy sport, the first example is sunny, warm, normal, strong, warm, same, and we are saying it is yes. Yes means positive example, I have told you right now. So here we are checking whether these both are consistent or not. What is the meaning of consistent? Okay, so let us see what is consistent here. I will show you with an video here. What is consistent means it is consistent with each and every example. Okay. So see, consistent I am showing here. The consistent values, this is the positive example and this is the total the negative examples and positive examples we are having here. The consistent, what it is going to separate the positive examples and it is going to separate the negative examples using a square bracket. Not consistent means it is not going to, sometimes the negative examples may come inside the square box. Square box is the version space. We have told that candidate elimination deals with the version space. So here, let us see what is this example. Consistent and non-consistent. Let us go to our subject now. So just now I have told you the consistent and what is not consistent here. So consistent values. So again I am going into I will show you what is all this. The machine learning algorithms just now we have discussed is a very, very important thing. So let's go to our subject. See. So which one? So just now I have talked what is a machine learning and what is a consistent. Now I am going to show you the current page. Okay. Let us see here. This is our example we have just now talked. I have told what is consistent, what is not consistent here. So here for the first example, this one. So I am checking whether G naught is consistent with the first example or not. Yeah, it is consistent. Again, I am replacing the G1 with the question marks only because it is consistent, it is proved. Next, coming to the S naught, we are having the null values. I already told that null values means that are not acceptable. So I am initializing S1 with the first positive examples. Okay. Next thing. Again, we were going to see the second example. What is the second example? I am having sunny, warm, high, strong, warm, same. Yes. Again, I am going to compare with the general hypothesis. What is the G naught value? G1 value we are having here question marks. So it is also consistent with that. So I am not going to change the values for the general hypothesis. As it is G naught, G1 will be the question mark. Go to the S naught values, more specific values. S naught values are not consistent. I have changed it to S1. We have replaced the values with the first positive example. Second, S2 values. So what you have to do, if any attribute is not matching, just replace that with a question mark. Okay. So here when I'm comparing here, second example, sunny, sunny, warm, but high and normal are there. So they both are not same. Then what we have to do as per the algorithm, we have to replace it with a question mark. So I got a question mark here, and strong are matching, warm are matching, same are matching. So there is no change. Only one attribute has changed for the S1 value. Okay. Okay, everything is completed here. So let us go to our third example that comes to the, now this is very much important. We know everything till fineness algorithm and candidate elimination algorithm, both are same up to positive examples. Then where we are getting the changes, only for the negative example I am getting the change here. Okay, so the negative example what I am having here is negative, means no value. When you have a no means it is negative. So I am checking with the, if it is negative example, I already told in the example, what I have told in the algorithm is, whenever you get a negative example, first you have to jump to the specific hypothesis. Till now for positive examples, we have started with the general hypothesis. But for negative examples, you have to start with the most specific hypothesis. So here the most specific hypothesis, what I am having the values here, sunny, warm, negative, we are having the question mark, strong, warm, same. So what are the negative values I'm having? Rainy, cold, high, strong, warm, change? No. In more specific hypothesis, so as it is a negative example, there is no need to change the S2 value. S2 is more specific. For the third example, I'm taking denotion as S2 here. So I'm not changing any values for S3 here. Sunny, warm, question as it is, I'm remaining at the same. Both are initialized same because it is negative, no need to change anything here. Then coming to the general hypothesis, it takes a lot of difference. Okay, so till now G0, G1, G2. For the positive, two positive examples, it is as it is question mark only. Then where is the change happening? As it is a negative example, the process will be somewhat different. Please note this one, everyone. So here we have sunny. First attribute, what I'm having, sunny. So just sunny, take all the question marks. Let's compare with all the attributes here. So sunny, all question marks. And next to attribute, what is the next attribute? You are having cold. What is the opposite for cold here? Warm. So I'm taking warm with all the question marks. Next, what is the attribute for humidity? High. What is the opposite in this? Normal. Normal and all question marks. Then what is opposite for warm here? Cool. So I'm taking the cool here. What is opposite for same? I'm changing the change is there for the negative example. I'm taking the opposite values. You understood, right? In the table, the negative example, in order to convert it to the positive example, you have to change all the values. Okay. So just nothing. We have to write the opposite for this. What opposite for? If the negative example is rainy, you have to take sunny. If it is cold, you have to take warm. If it is high, you have to take normal. If it is, see here in wind, negative and in humid, in wind, all are strong only. For positive example, it is strong. For negative example, it is strong. So I'm not, we have to ignore that example. Both are same. Okay. Just I am ignoring here. I have not written anything here. Okay. Let us come to same and change. So I'm changing here. Just remember that. Okay. So our G3 is initialized with these values. Next, come to our fourth example now. So let us see what it is having here. S it is having. Okay. S, once it is a positive example. Again, you have to jump to the most general hypothesis. So sunny, warm, high, strong, cool, change. Yes, we are having the attributes. So here you have to compare each and every value with that now. Okay. So I'm comparing the sunny with sunny. Okay, it is consistent. I'm comparing warm with warm. It is consistent. Whereas normal, where it is not having normal at all. So just I'm removing that attribute. Another, when I'm having the cool, but we are having only warm here. So I'm just ignoring that. And for same also, The same here we are having the change, whichever is opposite values, you have to just delete that values, you have to ignore that values. So therefore, the positive example for G4, we are taking only the two attributes, sunny question mark warm, because all are opposite to the positive example. I'm just ignoring everything. So just whenever you get a negative example, you should be very much careful while writing. You have to check you have to write the opposite of that, and you have to delete, you have to ignore everything. Okay, so till here I have completed. Then I'm again going to the most specific hypothesis, because I have to take the values for S4. So S4 values, what I'm having, sunny, warm, question mark, strong, question mark, question mark. I'm comparing here. So here when I'm comparing sunny, warm, question, high, question mark, as it is I'm taking as a question mark. Whereas strong, both are same. There is no need to change the value. When coming to cool, question mark, you have to take the question mark. Next for this, you have to take change. Okay. So the beautifully we have designed this everything with the positive and negative examples. So we will see the conclusion, what conclusion you have to take here. See here. So this is the example, enjoy sports. Next, what you are going to get, what is the output I'm going to get here. See, the more totally now I have removed S1, S2, everything I have removed. I have taken only the result. I have taken only the outputs now. So our most specific hypothesis, the output is sunny, warm, question mark, strong, question mark, question mark. And for most general hypothesis, we are taking sunny and warm. So if you are interested more, till you want to make more accurate output, then again you can apply the positive examples, where we are going to get these three examples, three values you are going to get. This is a very much important. The candidate elimination algorithm we are using for the concept learning. Concept learning means we are going to learn little about the universe. Okay. Hope we have advantages of concept learning also. What is the advantage? The first advantage is the improved accuracy. Why we are telling improved accuracy? Because finder's algorithm is unable to deal with the negative examples. We have very much accuracy here. So we are using both positive and negative examples in order to improve the accuracy of the output. What is the second one we have? It is very much flexibility, because it can deal with the complex problems. And what is the third advantage we are having? It is more efficient. Why it is? Because it is giving the results in a more faster than ever. It is going to give the results. Okay, let us see what are the disadvantages of here. So, yes, obviously, if we are dealing with positive and negative examples, and we are having a lot of writing than other examples, so it is using a highest memory requirement. And when by coming here, slower processing for the larger data sets. Yes, if the data is very much, any system will have a slowdown will be there here. These are the only the two drawbacks. It is having high memory requirements and slower processing if you use the large data set. And thank you everyone. I have completed the topic whatever I have told till now, and thank you so much. So till now we have talked about the advantages. Advantages are really very good, better with the finder's algorithm, because finder's algorithm can deal only with the negative examples here. So here it is having the high accuracy. Why we are telling the high accuracy? It is dealing with both positive and negative examples. Obviously we are going to get a more accuracy values here, more accurate output. The machine learning itself, why we are dealing with machine learning? Because we want a most accurate output here. So it is more flexible for the complex problems. Yes, it is more flexible, because we are till now the algorithms whatever are very accurate answers we are getting. So it is very much easy. So when coming to the disadvantages, we are having the higher memory requirements, slower processing I have told till now. So higher memory requirements, why we are having higher memory requirements? Because we are dealing each and every part of positive examples and negative examples. If you are using this much of data, obviously we are going to have a very high memory requirements. So coming, why the process is slower? So not only here, we can say if you are dealing with a large amount of data, obviously any system will get the slowdown. So here, as same the candidate elimination algorithm is also uses this, as we are using the large data sets, the system is getting slowed down here. So the good thing is we have covered the drawback in the finders algorithm, and it has been recovered in the candidate elimination algorithm. This is the very good topic. I hope everyone has understood. So thank you very much. Have completed everything with this topic. Thank you.